Mr. Ravi Prakash. Hello? Can you hear us?
Can you hear me?
Yes. Welcome. Welcome again at Summer Academy, Atlantykron. Ravi Prakash is landing engineer at JPL, Jet Propulsion Laboratory, NASA. We have some of our special guests. First, Sorin Repanovici, which is already know, the general coordinator at Academy Atlantykron. Then Dumitru Prunariu, which is our cosmonaut. Hello. And
Hello.
And beside me is Heather Caton, which is the president of World Genesis Foundation. Hello again and welcome to Atlantykron.
Thanks so much. Thanks for having me. This is exciting. I'm glad to be back.
Yes, that I want to say. Welcome back, man. So I understand that before to start to speak about Mars, I understand that you decide to actually you take a tough decision for your life. You're right. You join us. It's mean I have a family now, so you join us in the club, right?
Yes, absolutely.
Okay. Good luck, man. So
we won't say more about that, but
So, Ravi, a few words to you. I had the opportunity last year in Saudi Arabia to award Charles Elaki, your director, for this outstanding project, the Curiosity, where at the Congress of the Association of Space Explorers, all astronauts and cosmonauts of the world decided to award him for this project, the most important project of the century, I think. And we think that this will really be the most important project of the century if some slates of life will be discovered on Mars. And we really expected to see and to understand what happened millions of years ago on Mars. How Mars was alive, how was the landscape, how was the water there, how was the vegetation, and what happened in between, and what could happen with our Earth. If we understand the process, maybe we could save ourselves. What's your opinion about the discoveries, the last discoveries on Mars?
Sure. That's a great setup for the purpose of this mission, which is this Curiosity rover is designed to tell us, could Mars have had life in the past, and to explore Mars to see if it had water. And we found out, actually, within a few short months of starting driving, that the answer is a big yes. We discovered very quickly that there was bedrock. If you think of like a river, but the water is all gone. We discovered that very quickly on Mars, and so we know that Mars at one point had flowing water. That's very, very important because that means that because there's water, that means that there could have been life on Mars. And that's one of the many ingredients. And then shortly after, we did the first drill on another planet ever. We drilled into Mars, into a rock, and we found carbon and other ingredients. And that told us that Mars absolutely has the ingredients to support life because there's water. We knew there was water, and actually is water also at the north and south poles, where there's carbon, which is a very important ingredient for life. There's nitrogen. There's a whole host of other oxygen. There's hydrogen. There's all the ingredients you would ever want for life, and so we're very excited about exploring Mars.
Well, next question.
We're stunned by that.
We were
answer.
actually
There was
dreaming
a stunned
life on
silence.
Mars, you know?
We started to dream about this, yeah.
Actually, Curiosity was putting on Mars the largest module, the largest rover. It's a little bit less than 1 ton, 1 metric ton. And comparing with the predecessors, it's an outstanding realization to put such a big mass on another planet. What do you think will be the next project?
So that's a good question. Are you talking about eventually putting humans on Mars?
Yeah, why not? And when?
Yeah. So right now, you're right. We landed a 1-ton car on Mars. This was the biggest thing by far that we've ever landed on any planet. The previous Mars rovers, they were less than half that size, and so we had to invent a new way to land on Mars this time because that spacecraft was so big, the size of your car. If we want to land humans on Mars, we have to think of a whole new way to land on Mars, because to land humans on Mars means you have to land sort of a house. You have to bring food. You have to bring water. You have to bring a lot of things. You have to bring oxygen, because there's no oxygen on Mars to breathe. So you have to bring a lot of things with you. And they estimate that maybe you have to land, instead of 1 ton, maybe you have to land 70 tons, which is a lot more, basically much, much bigger. So imagine landing 70 Mars rovers. So how do you do that? We have to think of something new, and we have some ideas on how to do that. A lot of it is similar in that we will use rockets on the way down, but we have to think of a new way to do it, because this sky crane method, the method where we have rockets lowering a rope, might not work for something much, much bigger. And so we have many groups at JPL, at the Jet Propulsion Lab, thinking of ways where we can land humans on Mars, and we're very excited about those new options.
Ravi, Sorin Repanovici speaking. I got some information from BBC. Actually, they come out with some news regarding Curiosity mission over there, and we have some interesting information. Maybe you can add some more. For example, I understand that 119 gigabytes data was returned to the Earth, 36,000 full images, and also laser sensor has fired over 75,000 shots. You can add some interesting numbers or data. What do you have?
Yeah. The most interesting data to me is actually how far we've driven.
Okay.
This rover goes at a snail's pace. It goes very, very slow. And the reason for that is because it's so far away. So if you imagine, for example, on the day that we landed on Mars, it took 7 minutes for a signal from Mars to come to Earth. So that meant that when the spacecraft signaled to us that, hey, I'm about to enter Mars, by the time we got that signal, it took 14 minutes for that signal. So by the time we got that signal, it had been 14 minutes later. And from the point where the spacecraft entered Mars to landing on Mars was only 7 minutes. So if it sent a signal that took 14 minutes to get to Earth, it had already been on the ground for 7 minutes by the time we heard that it was about to enter Mars. So this time delay causes a lot of problems when we're trying to operate the rover on the ground. We can't just use a joystick and tell the rover exactly where to go. What we have to do is we send commands in advance, and we say, okay, rover, we want you to drive to this rock that's a few meters away. And if it comes into obstacles, maybe there's something in its way, it'll know that there's something in its way, and it will stop. And so it might take a really long time just to go a few feet, a few meters. So in 1 year's time, the rover has actually traveled only 1.5 kilometers. This is something that you could walk easily in a single day, in just an hour. You could walk more than that. But it's because this rover is so far away that we can only travel very, very slow in order to be safe. We're actually trying to improve the software on the rover to make it smarter. It's called artificial intelligence, and that will help it go farther without us telling it every single step that it has to go. So to me, the number that's most interesting is it's only traveled 1.5 kilometers.
Only one.
Yeah. Very slow. In fact, other things that are interesting is that the amount of science that this rover has done in a year, if you were to put a human geologist on Mars, they could do this entire mission that it's done in 1 year in only 2 or 3 days, maybe a week. And it's because humans have so much more brain power. We can look at something, we know exactly where to go. We can use more advanced tools. This rover is trying to imitate a human brain on Mars, and it's very, very hard to do that. So instead of making the rover very, very powerful, we have it take pictures, and people on Earth will come back and say, okay, I can see this picture, I know what's happening, instead of having the rover do that. So we have a lot of smart people on Earth telling the rover what to do, and then looking into the pictures, looking at the data and telling everyone else what is on Mars.
Ravi, just an information for all this public here with us. How many minutes takes the signal to go to Mars and to come back?
That's a good question. So it depends. So as you guys know, Earth and Mars both orbit around the sun. And for Earth, it takes 365 days. For Mars, it takes almost twice that. So one revolution around the sun for Earth is 1 year. One revolution around the sun for Mars is almost 2 years. So depending where the planets are in relation to the sun will determine how long that signal takes. It might take as much as half an hour for a signal to travel from Earth to Mars, and then another half hour for that signal to travel back to Earth. So at most about an hour. And when they're very, very close to each other, it might only take a few minutes. So maybe on the smaller end, it might take just 5 minutes. On the longer end, it might take an hour.
It was just to let people understand how difficult it is to control the rover from the Earth. If you want to tell the rover something and the rover to answer to you. Okay, now we want to introduce you a young boy who is the winner of a contest organized by NASA on space laboratories. He is Andrei Rotaru from the high school Traian from Constanța, and I give him the microphone. Maybe he has some interesting questions for you also.
Yes, please. Hello. Congratulations
Hello.
on your award.
Thank you very much. Yes, I have three questions. First is why the connection with the Curiosity rover takes only 8 minutes?
So, but already question because was give you by.
That's fine, yeah.
Okay, the second.
The second is what do you think about launching a new satellite in order to make the period longer?
Can you repeat the question? Which satellite?
What do you think about launching a new satellite in order to make the period longer?
Yeah, just so I understand the question, are you asking another satellite to make communication easier?
Yes.
Yes.
That's a great idea.
Yes, yes.
Sorry, if that's not your question, you can correct me.
What do you think about launching a new satellite in order to make the period longer?
No. Short.
Shorter?
Short. Easier.
Yes.
Oh, I see. So, that's a great question. So you're saying to make communication easier, to make it take less time, why not have another satellite orbiting Mars?
Yes.
That's a really good idea. So we actually sort of do that. The rover, usually we don't communicate with the rover directly from Earth. What we do is we communicate with a satellite orbiting Mars, and that satellite talks to the rover for us. That has a few benefits. So as you know, about once a day, a day on Earth is 24 hours. A day on Mars is 24 hours and about 30 minutes. That means that Mars travels about the same, it circles its orbit about the same rate as Earth. And so, half the time the rover is facing away from Earth, so we can't communicate with it. But what we can do is we can talk to the orbiter that's hanging around Mars, and that orbiter will catch up to the rover sooner, and then that orbiter will talk to the rover. So because of the orbiters, like your idea, we can talk to the rover about twice as often as we would otherwise. So that definitely helps our communication with the rover. Good question.
Okay. And the last question is what measurement have you taken launching the Curiosity rover in order to be sure it will land safely on Mars?
What measurements did we take for the rover to be safe on Earth? On Mars, sorry.
Yes, yes.
Yeah. So that's a really good question. So we took many measurements as we were landing on Mars. This included the rover's position, its what we call attitude, which is the angle that it was. You can think of it as the orientation of the rover. And we did that the entire landing sequence. So we knew, and how fast it was going. So we knew that when it touched the ground, that the speed had stopped, the velocity had stopped. We needed to position, was it moving anymore? We couldn't measure that we were on the surface, but we could measure that the rover stopped moving. And we knew that the rockets didn't need to fire anymore. And so at that point, we cut off the bridle and we had the rocket fly away. And then, as the rover's moving on the ground, we take lots of pictures. And the pictures help us the most understand that the rover is safe and help us to understand Mars as well. I hope that was your question. I'm sorry if it wasn't.
Yes, it was. Okay, thank you very much.
Thank you. Good. Yeah. Good.
Hey, Ravi, this is Gabi Valsan speaking. It's been a year actually since we have these multiple eyes of Curiosity rover on Mars, preparing possible human missions. A quick question: what's the life expectancy of the Curiosity?
Yes. So before I talk about Curiosity's life expectancy, I'll give you some background. And the Mars rovers that went before Curiosity, they were named Spirit and Opportunity. They were designed to last 3 months, 90 days. And they both lasted over 8 years. And the reason is because as we can't go back to Mars and have a human fix something, we designed it to be very, very strong. And so in that case, we designed the solar panels, that the Spirit and Opportunity rovers were powered by the sun. And occasionally dust would get on the solar panels and that would decrease the power that it got. And we estimated that the solar panels had to be as big as they are in order for the rovers to last 3 months. What happened in that case is that wind blew away the dust and it cleaned off the solar panels. And so it gave the rover more power than we thought. And those rovers lasted really long. The Curiosity rover is nuclear powered. So we don't rely on the sun. And we designed this rover to last 1 year on Mars, which is about 2 years on Earth, because it takes Mars twice as long to go around the sun. And we expect it, as long as nothing breaks, it can last for a very long time, so maybe five years or so. So we won't be surprised if this rover lasts a very, very long time.
What will be the next mission to Mars that NASA is preparing, if you know? What will be the next mission?
So we are doing something, the next mission to Mars. So we are doing something very similar as far as the next rover goes. The next rover is going to launch in 2020. It's going to look very similar. It's going to land the same way, where we use the same sky crane concept. And it's going to, the rover will look almost exactly the same. The difference will be the instruments that we put on the rover. So we'll have a different set of instruments, science instruments, more sophisticated instruments. So we can look deeper into Mars. We can perhaps drill deeper. We can do more advanced science on Mars with the same rover. But before we send that rover, we're actually going to send a lander to Mars. A lander is something that lands on Mars, but it doesn't move. It doesn't rove around, so it has no wheels. It'll look a lot like the Phoenix lander, if you're familiar with the lander. That went to the North Pole, but this one is going to land at the equator of Mars. And it's going to launch in a couple of years. And then we're also sending an orbiter around Mars to analyze the atmosphere of Mars. So there's 2 missions that are going to go before this next rover goes to Mars in 2020.
Does this next rover has already a name?
The next rover does not have a name, and actually it's usually a contest. And so kids from around the world can write and suggest a name, and they can write an essay as to why they think it should be that name. So I encourage all of you to do that whenever that time comes, which might be a few years away, probably 2016 or so.
That's the reason I ask, because I know, I'm not sure, but you can confirm that also for Curiosity was a contest for the name. Mm-hmm. Okay, so all the kids in the world can participate to give the name to the new rover.
That's right, you should all start thinking of them now.
Yeah, sure. Does the new rover will have technology to harness possibly the water and oxygen from the rocks of Mars, from the soil of Mars, preparing for a mission with humans?
I'm sorry, can you repeat that question?
Well, I'm thinking that if the question is if NASA is developing already technologies that are capable to harness water and oxygen from the Mars soil in order to prepare a human mission to Mars.
That's a very, very good question. And basically the question is, what are we doing to prepare for human exploration on Mars? And we are looking at how can we convert what's already on Mars into drinkable water? Because there isn't really drinkable water on Mars, even though Mars had water long, long time ago, all that has dried up. And so we need to find a way to make water out of what's already there. And we have people, guys and girls, engineers and scientists, looking into how do we make water on Mars. There's also the question about food. How do we grow food on Mars? We want to make sure that there's enough for the astronauts to eat. And so we can look into growing plants, we can go into growing fruits and vegetables, and have all sorts of these food in some sort of habitat on Mars. So we have people looking into creating food, water, and even oxygen somehow on Mars. And that way, if we can do it on Mars, we don't have to bring it from Earth, and that will save us a lot of time and money, and we'll have a more successful mission that way.
Thank you, Ravi.
Yeah. Who here wants to go to Mars, by the way? I'm curious. How many of you kids want to go to Mars?
Everybody, cine vrea să zboare pe lună?
Hands up.
We have a lot of
More than 20.
Not only kids.
Întrebări din public. Domnul profesor Zăgran? Nu? Întrebări?
We are asking the public if they have some questions, quick questions.
Some additional.
Okay. No questions. They are ready to fly to Mars without any other questions.
Good.
So after a year, Ravi, we got a lot of information about Mars, and it's another proof that always science fiction's ideas come to be true. Now it's time for Mars, but I'm sure soon we're looking for a different planet. What do you think?
Or a satellite of a big planet.
I missed the very last part of that. Looking for
Another planet. Other
oh,
stars.
another planet. Yes, yes. There are. So my favorite planet is actually a moon. It's called Europa. It's a moon of Jupiter.
That's right.
And yeah, Jupiter. Thank you. And it's basically an ice ball, and we think that under the ice is liquid water. And if there's liquid water, there's some chance that there could be life under there, and maybe some sort of sea creatures. So my favorite planet that I want to go to is Europa, which is the moon of Jupiter. And NASA is actually looking into going to this moon to see if there is life. The problem is it's very far away. It would take maybe 8 years to get to, because Jupiter is much, much further away than Mars. And it's a much more costly mission. This Mars mission, this Curiosity mission, cost about 1.5 billion euros. This Jupiter mission would cost maybe twice that. And so we have to think about, would we rather send maybe 2 missions to Mars or 1 mission to Jupiter, or other things like that. We're also looking into going to Titan. Titan is a moon of Saturn. We've been there before. In fact, the European Space Agency sent a probe called Huygens to Titan, and it's another place where maybe there is some sort of life, like some sort of microbes or something, because we know there's carbon on Titan.
How soon we'll have people on the moon? Because we speak about the moon, but how about our moon? How faster? In the last half of century, we're doing so great things, I mean humanity. What do you think when we will move to the moon? We hear different stories. We have a yellow moon, you know what I mean? We can have different kind of color of moon.
We have a honeymoon also.
Gotcha.
I recently went on one of those honeymoons.
Congratulations.
We actually recently sent a couple satellites to orbit the moon, our own moon, and they were called Grail, and their mission was to map the gravity of the moon. And so they did that, and now because they did that, we understand better about how the moon was formed. We did talk about sending humans back to the moon. I think that would be very exciting, but that program ended up getting canceled just because of cost. And so we have to keep pushing on our politicians to go back to the moon, especially with humans, because I think that gets people more excited about space. That'll get kids more excited about science, and hopefully we'll see one of you on the moon one day. If not Mars.
I understand wrong, or you say to send politicians to the moon
And leave them there. So actually, you know, not far away, the NASA administrator, Charles Bolden Jr., announced about a mission to an asteroid, to catch an asteroid, put it on an orbit around the moon, and send a crew to study the asteroid.
That's right. So one of the missions that NASA is currently looking at, and it looks like maybe it will happen, is going to an asteroid. And I think, maybe correct me if I'm wrong, but I think this mission will have humans on it.
Yes, that's right.
Yeah. And so it's an interesting problem because asteroids, they're usually tumbling. They're usually not like Earth where it's nice in a smooth rotation. They're usually tumbling all over. And so the spacecraft will have to sense that the asteroid is tumbling. It will have to match that same sort of tumble and then land on the asteroid. And so that's an interesting engineering challenge. And I think it will also be fun for the astronauts to maybe maneuver around and to land on the asteroid and then collect a sample maybe, like you said, maybe lasso it and then take it around the moon. That's an interesting problem that they proposed.
And to close, thanking WGF.
I have just a short last question. You know, many people say that when you have a goal, more like a dream, and you strongly believe in it, it really happens. So, as a kid, did you have a dream of being an engineer at NASA, or it just happened?
For me,
Yes.
For me, it was so actually all of my life I wanted to be a doctor because my dad is a doctor, and it wasn't until senior year of high school that I decided, until I was in 12th grade, that I decided that doctors worked too much, and so I wanted to do something else. And I decided that my parents took me to a NASA center near their house, and I was very excited there. And so I decided at that day that I wanted to be an astronaut. And so that's when I switched from wanting to be a doctor to doing engineering. I did aerospace engineering. And I think this sort of just came out because the moment I decided I wanted to do aerospace, at that moment I wanted to work for NASA. And so everything I did at that point was to, how do I get a job at NASA? And so it was a lot of studying, a lot of hard work. I was lucky. I think it did involve some luck for me because I got an internship at NASA, and that helped me to understand what engineers do at NASA. And from there, I continued to get a master's degree in aerospace engineering, and then I got a job at the Jet Propulsion Lab. And so it was a combination of some luck and some hard work, a lot of hard work, and mostly the willpower. It was mostly if it's something you want hard enough, you'll do whatever it takes to get it. And it was because I wanted to work at NASA, I just worked really, really hard. And luckily it worked. But it didn't have to work out. And if it didn't, that would have been fine too. I would have known that I tried, and I would have done something else that was maybe not for NASA, but I would have done space exploration through a different company. Because luckily in the US, there are a few companies that do space exploration. And we're lucky here, and we're hoping to spread that around the world.
Thank you. I hope this... I hope this will give hope and energy to our kids to fulfill their dreams and to go through science.
Yeah, Ravi, I think that you are an inspiration to the awesome power of dreaming in itself. So thank you so much. And from all of us here at Atlantykron and World Genesis Foundation, thank you so much for taking the time to be with us tonight. It's exciting to see you another year, and we look forward to the future. Thank you. Mulțumim.
so much. Thank you guys so much.
Have a nice day there.
Bye-bye.
And nice honeymoon. It's okay if I stay there?
Thanks. Thank you all so much. It was a pleasure being here again. I love doing this talk, and I hope I can continue.